Hello everyone. So today we are going to solve another interesting problem number 1590. Make sum divisible by p. And the problem says we have been given an array of positive integer nums. Remove the smallest subarray, possibly empty, such that the sum of the remaining sum is divisible by p. If not, allowed to remove the whole array. And return the length of the smallest subarray that you need to remove, or minus 1 if it is impossible. A subarray is defined as a continuous block of element in the array, and we have been given this example. So this problem is quite similar to problem subarray sum divisible by k, or the continuous subarray sum problems. And the general approach for this uh, problem, for these kind of problems, are we keep one running sum and we keep one hash map to check the index of this running sum, and as per the problem we update the hash map and the running sum as we are traversing. So for this problem, what I'm going to pick this example that nums is 6352, and going to apply my algorithm and see how we can solve this problem using the algorithm that I'm going to show you. So we have been given this nums and the integer p, which is 9. So what we need to do is, the very first thing that we can see is the minimum subarray that we need to remove. We can first find that we can find by, let or that would be, first we need to find the total sum of these given elements from the nums, so which is 6 plus 3 plus 5 plus 2. So this is basically 16. 11 plus 5, 16, and if 16 divided by 9 is 7, and so we need to remove subarray which has sum of 7, and out of these we find that there are two subarrays which have sum 7, which is 6 and no, so there is only one subarray, 5 and 2, as per the problem, which has a sum of 7. And after removing this from the original 6, 3, 5 and 2, we will be left with the just with the array 6 and 3. So yeah, so this is what we have to do, and we need to do this programmatically. So what we'll do is we'll first calculate the running sum. So the running sum would be for every, so we have this original list nums, and the indices position are for these values would be 0, 1, 2 and 3, and we'll calculate the sum as we'll iterate the original array. So that would be, the running sum would be 6, 9, 14 and 6. Then what we'll need to do is we will take the modulus to find the remainder for each running sum that we are going to find. That would be 6, 0, 5 and 7, and then the original remainder that we have found. This was the original remainder. We need to subtract it from the remaining sum to see which number, which sum lies in our hash map. So this would be -1, -7, -2 and 0. And we can make this sum s minus running sum minus remainder to be positive uh, by adding the original p integer that we have been given, but it doesn't matter, so I will not go with that. And now what we need to do is we need to, this remaining sum that we have after taking out the remainder, will modulate it with the original integer p that we have been given, and we'll see that what is the number that we are looking for. And if we find this number in the, so this is in the original in our hash map, then we'll say that yes, we have found our subarray of minimum length that we need to remove. Otherwise we'll just uh, keep finding it. So s minus, so running sum minus remainder modulus p would be after taking the, uh, so if I add the remaining, if I add the original integer in this, so this would become 8, 2, 7 and 0. And now we need to take the modulus with the p, so this would be 8, and then this would be 9 modulus 2 will give me 7 back. This would give me 2 back, and original is 0. The last is 0, and now we need to see which of these element lies in our. We'll check this target lies in our original count of hash map of sums, where we will be storing the hash map with their indices, and if we find them, then we'll update our answer to return the minimum subarray that we need to remove. So this would be the approach, and now let's get into the coding part, and I'm going to show you how we can reach to the output that we are looking for. So the first thing that we need to do is we need to calculate the total sum of the original array. So that we'll do by using the sum operator from the Python library, and then we need to find the remainder. So the remainder is sum modulus p. This will give us the remainder, and we need one running sum to calculate our running sum in the array, and we need one hash map which will be mapping with the running sum and their indices, the indices of the running sum. So for the first time, the running sum is 0. There is no index in the original subarray, in the original array nums. So we'll be initialize it with -1, and now we'll iterate in the given array, and we'll calculate the running sum. So for that we need just s plus number which we have encountered, and we'll find the modulus with the given integer, and now we need to find the target. The target is, which I told you, that it is running sum minus remainder original, and we'll take the modulus out of that. So this is the target which we are looking for. And if this, and we need one, we need to update our hash map with the running sum values, or in which we have found the index. So that would be, that we can do with storing the key with the value of I. And now we need to check if our target is in this hash map that we have defined, and if it is, then we need to update our answer, and our answer will be, so we need to define one answer as well. So initially answer would be the original length of the subarray, or original length of the array, and if we have found this target which is lying in our hash map, then we'll say that I give me this target value from the hash map, and I'm going to subtract it with the index where I am. So that will give me the position of this subarray that I need to remove from the original list. So that's that, and in the end we'll just return our answer that we have found. And so there could be one edge case of If we have seen, if the remainder is 0, then in that case we just need to return this remainder directly. Now let's run our solution and see how it performs. No, this is nums. So it has been accepted, and now let's submit our solution for all the problems. So that has not been accepted. Okay, so we need to update our answer as per the suggested. Okay, so we need to update our answer. If we have not found anything, so we'll say that we'll return -1. If our answer is equals to the original length that it was, otherwise we'll return the answer that we have found. And this should work for the input 1 2 3, and with the division integer p is 7. Now let's run it. Okay, yeah, this has been accepted. Now let's submit it for all the example test cases. Okay, so that has been accepted as well. So this is the approach for solving this problem number 1590, make sum divisible by p. And please let me know if you have any particular problem for me to solve. I will be very happy to have a look. And please like and subscribe to the channel. It helps the channel to grow and I would be able to bring more such awesome content for you guys. And thank you. Have a nice day.